Today we're going to be talking about the FRQ topic of graphical analysis, also called fundamental theorem of calculus. We're going to be using that in several ways while we're doing a graphical analysis. Oftentimes in these problems we are given that a function, say g, is the integral of some other function like f. There will be x's somewhere in these boundaries, okay? Because g is a function of x, we're going to need x's in the boundaries. Oftentimes you'll see a t over here, so that there's no confusion, because when you have x's here and t's there, it could look confusing. And then you're going to be given the graph of f, okay? In each of these, the first thing that we're going to do is we're going to take the derivative of g. So g is this integral, so g prime will be the derivative of this integral. And the derivative of this integral, we're going to be using the second part of the fundamental theorem for that, and that is we start up at the top, take the derivative of that is 1, and then we're going to put x in for t. So this would be 1 times f of x minus, and now we would go to the bottom boundary, take its derivative. The derivative of any constant is 0, and then you would put a in for t. This ends up being just f of x, because 0 times f of a is 0. So that happens quite often. Not always, but often, all right? So this graph that they're giving you, if they give you the graph of f, they're also giving you the graph of g prime. Another way I've seen problems is they just flat out say this is the graph of g prime or f prime or something. Either way, you're going to be looking at the graph of the derivative of that function. All your questions will deal with the function that you're given here. You're going to examine the graph in a wide variety of ways. These are just some of the ways you're going to use the graph. You can see where g is increasing by looking at the slope, by looking at the sign of the graph. G decreasing. G has a relative max when g prime goes from positive to negative. Things like that. G is concave up when g double prime is positive, so the slope of the graph is positive. Concave down when g double prime is negative, so the slope of the graph is negative. G has a point of inflection when g double prime changes signs, so you'll be looking for where does the slope of the graph change signs. Things like that. Just some of the questions you could be asked. You will also use the graph to find values of g. This will also involve the fundamental theorem of calculus. Okay? We will use the signed areas under the curve for that. Be sure to first set the integral up. Okay? And here was an example of that. So, let's see what else I have. Like we did with in previous sections, any value is the initial value plus the change in the values. So that's another way to use the fundamental theorem of calculus. For any absolute max-min questions, set up the closed interval test, the candidates test. Okay? Alrighty. Let's take a look at a problem. Okay, this first one that we're going to do is back from 2017. This was number 3. Almost all of these are going to be with no calculator. The function f is differentiable on the closed interval -6 to 5 and satisfies f of -2 is 7. They're giving us an initial value of f. Okay? The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments, as shown in the figure on the right. So this is the graph of the derivative. So in this problem, they didn't give us it where g was equal to the integral of f or whatever. But the questions then will all deal with f, because there is no g yet. Maybe it'll be here later, but not yet. All right, part A, find the values of f of -6 and f of 5. So we're going to use our initial value and the change in the value. So we're setting up the fundamental theorem of calculus. I'm trying to decide which way to set it up for you guys. I think I'm just going to do it the way that we always did it in class. So the integral of f prime gives you back f, right? The integral of f prime gives you back f, and that's what we're looking for. We're looking for f, yeah? Well, I have two x values. I have -2 and I have -6. So I'm going to apply those to my boundaries, putting the smaller one at the bottom and the larger one at top. So -6 is going to go to the bottom, -2 is on top. So this will be f of -2 minus f of -6. Okay, let's take a look at this integral. For this integral, we're going to be using the signed areas under the curve from -6 to -2. So I'm going to go to my graph, -6, 1, 2, 3, 4, 5, 6, -6 to -2. I want the signed area between the curve and that x-axis. So I want this area. So this is going to be, it's a little triangle, 1/2 base times height. The base here is 4. The height here is 2. So that is the integral. F of -2 is 7. And we are looking for f of -6. Since f of -6 is negative, I'm going to take it to the other side, leaving the 7, and then I'm going to subtract this amount to the right-hand side. Half of 2 is just 1, so I'm just going to subtract 4. So f of -6 is 3. We're going to do the same process for f of 5. The integral of f prime gives us back f. Now we have 5 and -2. So in this case, the -2 will go on the bottom and the 5 will go on top because 5 is bigger than -2. So this will be f of 5 minus f of -2. So from -2 to 5, I'm going to get another color here, -2 to 5, 1, 2, 3, 4, 5. I need the signed areas between the x-axis and the curve for this. So we're going to need this area. For the integral part of that, it's going to be negative because that area is below the x-axis. And then we're going to add this area, and that's going to be a positive because it's above the x-axis. So below the x-axis, that's half of a circle, so 1/2 pi r squared, where r is 2. And I make that negative because it's below the x-axis. And then I add to that this triangle, 1/2 base times height. The base is 3, the height is 2. That's the integral. And this is equal to f of 5, which we're looking for, minus f of -2, which was given to us to be 7. And f of 5, I'm just going to leave it on the right since it's already positive, and I'm going to add the 7 to the other side. And I'm just going to write it exactly like I see it. Remember that we don't have to simplify. So there is your f of 5. Okay, the way this was scored this year was, this whole thing was worth 3 points. 1 point for uses initial condition. 1 point for the answer to f of -6, 1 point for the answer to f of 5. Okay? Part B. On what intervals is f increasing? Well, in any function, f is increasing when f prime is positive. That will be our justification, f prime positive. Well, this is the graph of f prime. Where is this graph positive? This graph is positive wherever it is above the x-axis. So f prime is positive from -6 to -2, and again from 2 to 5. So I will say that -6 to -2 and 2 to 5, since f prime is positive. That's it. Okay? For increasing or decreasing, technically we include the boundaries. However, for increasing and decreasing, you will be given credit whether you include those boundaries or not. But technically it includes it. If it had said strictly increasing, we would not include it. Okay? This was worth 2 points. They said 2 points for the answer with justification. Let's see. Find the absolute minimum value of f on the closed interval. So absolute min, I'm going to set up the candidate's test. Our independent variable is x. We're finding the minimum value of f, so f needs to go right there. We start with the candidates for x, we start with our boundaries. And then we include any value of x that makes f prime equal to 0, or f prime undefined, because those also would be candidates for the location of the absolute minimum value of f. Okay, so I need to come over here and examine f prime, the graph of f. Well, the graph of f is 0 at -2 and 2, right? -2 and 2. So -2, I'm going to say what I did. F prime is 0 at x equals -2 and 2. Okay? Now, I will say this. -2 and 2 do both make f prime 0. However, at -2, f prime goes from positive to negative. Since f prime is going from positive to negative, that means at -2, f has a relative max. F has a relative max when x is -2. We're looking for an absolute minimum value. Can the location of a relative max be an absolute min? No. So this value I didn't have to put on our candidates test because it's not going to be the location of an absolute min. All right? But putting it there is okay. It doesn't really matter. We can include that or not. If you include it, though, you're going to have to make a statement or find the value right here. Okay, now to complete our chart, I need f of -6, I need f of 5, I need f of -2, or to make a statement saying that that's the location of a relative max, and I need f of 2. I need all of those. F of negative 6 we found in part A. I already know that that's 3. F of 5 we also found in part A. It's a bit of a mess, but we found it in part A, right? I'm going to clean that up down here. So f of 5 is, okay, 7 minus 2 pi plus 3. So that is 10 minus 2 pi. Okay? F of negative 2. Oh, well this actually turned out okay because f of negative 2 was the one that they gave us. It was the 7. So that's easy to slap down there. I don't have to make a statement about that being the relative max. Okay, for f of 2 though, we're going to need to do a little work because f of 2 we did not find in part A and it was not given to us like f of negative 2 was. So we got to do a little work to get there. So f of negative 2, to find it, I'm going to do the same process that I did in part A. The integral of f prime gives me back f. I was given negative 2. I was given x equals negative 2, and I need to find 2. So this will be f of 2 minus f of negative 2. The integral from negative 2 to 2, negative 2 to 2, that's that negative 1/2 pi r squared. So that's our negative 1/2 pi times 2 squared. And that will equal f of 2 minus 7. Pull your 7 over. That'll be 7 minus 2 pi. And that's f of 2. 7 minus 2 pi. Okay, we want the absolute minimum value of f. These are the only candidates. So which is the lowest value? Which is the lowest value? Well, pi is about 3 point something, right? So 2 times 3 point something is about 6 point something. 10 minus 6 point something is 3 point something, which is bigger than 3, but 7 minus 6 point something would be less than 3. So the minimum value of f is 7 minus 2 pi. Did they ask for the x value at which it occurs? They did not. So we don't have to give it to them. If you want to say at x equals 2, fine, but they didn't ask for it. Our justification is the work that we showed. Full credit. This year, this was worth only 2 points. Usually an absolute min-max is worth 3 points, but this year it was only worth 2. 1.4 considers x equals negative 2. I'm sorry, positive 2, not negative 2. And then 1 point for your answer with justification. So 2 points for that one. 3 points for part A. 2 for part B. So looks like we have 2 more points to gain. For each of f double prime of negative 5 and f double prime of 3, find the value or explain why it does not exist. Okay, well, f double prime is the derivative of f prime, so it is the slope of f prime. And f prime is the graph that we were given. So if they want f double prime of negative 5, we want the slope of f prime at x equals negative 5. So here's here's the graph of f prime. 1, 2, 3, 4, 5. Here is f prime of, this is f prime of 5. We want the slope right there. What is the slope right there? Well, the slope right there is down 2 over 4. Negative 2 over 4. Oops, can't see that. Negative 2 over 4, which is negative 1/2 if you want to simplify that, but we don't have to simplify that. Okay, f double prime of 3. We're going to do the same thing at 3. Okay, at 3 we are right there, so this is f prime of 3. What is the slope right there? Well, the slope right there does not exist. Why? Because there's a cusp right there. Now, when you say cusp or corner, you need to be specific. Be specific. You need to name the graph and name the x value. Okay? So f double prime of 3 does not exist, since f prime, that's the name the graph, has a cusp at x equals 3. Name the graph, name the x value. Okay, this was worth 2 points. 1 point for f double prime of negative 5, and 1 point for f double prime of 3 does not exist with reason. Okay, so that was the question from 2017. The next one that we're going to do together is the question from 2021. So I'll let you guys grab that while I grab my boring guidelines here so I can tell you what it was worth each step of the way. All right, 2021. All right, let f be a continuous function defined on the closed interval from negative 4 to 6. The graph of f, consisting of 4 line segments, is shown on the right. Let g be defined by this integral. G is defined by that integral. Okay. Well, immediately in my response, I'm going to write g is this integral. So g prime is the derivative of that integral. Start at the top, take the derivative, that derivative is just 1. Then plug that top boundary in for your variable. So f of x, 1 f of x, minus the derivative of 0 is 0, f of 0. That is just f of x. So g prime is f of x. This graph of f is also the graph of g prime. Okay. Also, let's go ahead and find the second derivative. We always need it in these problems. If g prime is f, what is g double prime? Well, that would be f prime, which is the slope of f. Okay? So for g double prime, we're going to be looking at the slope of f. On what open intervals? They're telling us to write open intervals. Do not include the boundaries. On what open intervals is g concave up? Well, g is concave up when g double prime is positive. So I would like for g double prime to be positive. That means I want the slope of f to be positive. And the slope of f is positive here and there. So negative 4 to negative 2. Make sure you get the x values, not the y values. Negative 4 to 2. And 2 to 6. Since g double prime is positive there. Or you could say, since the slope of f is positive there. That's another good way to say it. Okay? You could also say, since f is increasing there. F is increasing on those two. Several different ways to say that. Let's see what they scored this as. They scored this one. I'm on the wrong problem. I'm on 2018. Let me grab 2021. Here we are. Okay. They scored this, first of all, 1 point for saying that g prime of x is f of x, and then 1 point for the answer with reason. So 2 points so far. Part B. Let P be this function. Find P prime of 3. Well, P is a product, so I need to use the product rule to find the derivative of P. So first I'm going to find P prime of x, and then I'll plug in 3 for x. The derivative of G is G prime times f left alone plus, now the derivative of f, times g left alone. Okay? Plug in 3 for x. I need g prime of 3 times f of 3 plus f prime of 3 times g of 3. G prime of 3, since g prime is f, g prime is f, this is f of 3, so I go to 3, f of 3 is negative 3. So this is negative 3 times f of 3 is still negative 3 plus f prime of 3. F prime of 3 is the slope of f at 3. The slope here is up 1 over 1, so that slope is 1. And then g of 3. For g of 3, I need to go to my definition of g. G of 3 is the integral 0 to 3 of f. All I did was plugged in 3 for x. That's all I did. The integral 0 to 3 of f is the signed area under that curve from 0 to 3. So from 0 to 3, what is the signed area under that curve? Well, I notice here that I have this area and I have this area. The areas are identical, but one is above the x-axis and one is below the x-axis. So because of that, they're going to cancel each other out. So all I need to do is find this remaining area over here, and that will be the integral from 0 to 3. And that area is 3.5, but it is below the x-axis, so this is going to be a negative 3.5. So g of 3 is negative 3.5, and I'm going to say stop right there. No reason whatsoever to simplify that. This was worth 3 points. 1 point for the product rule, 1 point if the student got either g of 3, that was what we did over here, or g prime of 3, correct. That was what we did here. So if you got either one of those, you got that point, and then 1 point for the entire answer. Okay, part C. This was a little different problem this year because they did so many different things in it. It wasn't our usual, you know, does F have a point of inflection or whatever. It's a little bit different. But all of these questions are different, so this shouldn't surprise us. Okay, now we are asked to find a little limit. The first thing we always do when we're looking at a limit is to plug in that x value in for x. g of 2. G of 2. Well, g of 2 is, remember they gave us the definition of g of x, so we're putting 2 in for x. G of 2 is the integral 0 to 2 of f, right? Well, from 0 to 2, those were my two areas that canceled each other out, so this is 0. If I plug in 2 to the denominator, I also get 0. So limit as x approaches 2 of g of x over x squared minus 2x results in the indeterminate form 0 over 0. When you get 0 over 0, we're going to use L'Hopital's rule. But we have to justify using L'Hopital's rule. So this is the key to it. This is your justification, what I have here, and I shouldn't box it because it's not my final answer. But what I have there, that's your key whenever you need to use L'Hopital's rule. Whenever you get 0 over 0, write this down. Rewrite your limit, results in the indeterminate form 0 over 0. Now we use L'Hopital's rule. Rewrite your limit, derivative of the top over derivative of the bottom. The derivative of the top is g prime of x. The derivative of the bottom is 2x minus 2. Now we're going to do the same thing by putting 2 in for x. G prime of 2. G prime of 2 is f of 2. Right? Because g prime of x is f of x. So g prime of 2 is f of 2. F of 2 is negative 4. So we have negative 4. 2 in for x here. We're going to have 4 minus 2. That's 2. So that limit is negative 4 over 2, which is negative 2 if you want to simplify. 1.4 justifies and uses L'Hopital's rule. 1 point for your answer with justification. Okay? Part D. Find the average rate of change of G. Average rate of change of G from negative 4 to 2. Change in G over change in X. Average rate of change is that. So G of 2 minus G of negative 4 over 2 minus negative 4. G of 2 we found up here, that was 0. Did we find G of 4? We did not. I need to go off to the side and find G of 4. G of 4, I'm using my definition of G, which is 0 to x of f. 0 to 4. 0 to 4. Well, 0 to 4 this time. These two areas cancel each other out, so now I'm finding this area, and it's going to be, the integral is going to be negative because this is below the x-axis. 1, 2, 3, 4, 5, 6. So that is going to be a negative 6. So 0 minus negative 6 over 2 plus 4. So that is 6 over 6. That is, hang on, something is off here. what did I do? Oh, I did 4. I did 4, and I didn't want 4. I should have done negative 4. Okay, glad I caught it now. Okay, so I'm going to get rid of this thing. All right. We want negative 4, not positive 4. Okay. So, well, 0 to negative 4, I don't want. I want that to be negative 4 to 0, the lower to the higher boundary. We can flip the boundaries if we make it the negative of our integral, right? So we want negative 4 to 0. Okay, let's come back up here. Negative 4 to 0. We want that area. Okay, all this area. Okay, the integral is going to be positive because the integral is because this is all above the x-axis. So let's count this up. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then I have these two little pieces, and together they make 3. So 13 plus 3 is 16. So that is 16. So inside here, I'm going to have 16. Oops, where you can see it. 16 right there. I'm sorry. The integral is 16. Goodness gracious. The integral is 16. So inside here, I need a negative 16. Gosh darn it. Negative 16. Okay. So g of 4 is a negative 16 because that minus out in front of the integral. Okay, so this is 16 over 6. Reduce it if you want to. Okay. Does the mean value theorem guarantee a value c between negative 4 and 2 for which g prime is equal to the average rate of change? So in essence, can we use the mean value theorem here? Well, for the mean value theorem to be able to be applied, we need for the function g, we need for g to be continuous on the closed interval and differentiable on the open interval. So that's the big question here. Is g continuous on the closed interval and differentiable on the open interval? Well, think about this. G prime is f. That was the first thing we did in this problem. G prime is f. And there's f. Here's f. F is defined. I can see every value. F is defined and continuous. F is G prime. That means G prime is defined and continuous. Well, if G prime is defined, then G prime must exist. Therefore, G must be differentiable. G is differentiable from negative 4 to 2. So G is continuous also from negative 4 to 2. Therefore, the mean value theorem applies. And yes, it does guarantee that. So they awarded 2 points for this. 1 point for the average rate of change, one point for the answer to the MVT question. I'm just going to call that answer with reason. Okay, I can tell when I start to mess up that I need to stop making videos for the day. I've made too many videos today. Okay. My screen went off. Anyway, so I need to stop now. Alrighty.